recording something and all and. Welcome students. Welcome to St. Joseph's open web-based learning platform. So we learn for a soulful and enriching e-learning experience. Welcome to Department of Mathematics. Our topic name is Differential Equations. Instructor for this chapter B. Bharati, MSc, Mathematics, Assistant Professor, Department of Mathematics, St. Joseph's College for Women, Autonomous, Vishakhapatnam. Let's see the learning outcomes. By the end of this chapter, students are able to understand what a Bernoulli's differential equation is and how to identify it from other types of differential equations. Second point, able to recognize the standard form of a Bernoulli's differential equation. Third point, able to learn how to transform a Bernoulli's differential equation into a linear differential equation through the appropriate substitution. Fourth one, able to gain the skills to solve the resulting linear differential equation after transformation. Let's see the content of this topic. Introduction to Bernoulli's equation, definition of Bernoulli's equation, derive the solution of Bernoulli's differential equation, and related examples. Let us see the introduction to Bernoulli's differential equation. In mathematics, an ordinary differential equation is called a Bernoulli's differential equation if it is of the form y dash plus p of x into y is equals to q of x into y power n, where n is a real number. So that Bernoulli's equations are special because they are non-linear differential equations with non-exact solutions. A notable special case of the Bernoulli's equation is the logistic differential equation. Let us see the definition of Bernoulli's differential equation. A Bernoulli's differential equation is of the form dy by dx plus p of x into y is equals to q of x into y power n, where p and q are continuous functions on a given interval. Note that if n is equals to 0 or n is equals to 1, then we have a linear differential equation. But what if n greater than 1? Our goal is to take this non-linear differential equation and turn it into a linear differential equation. That is, any differential equation is of the form dy by dx plus p into y is equals to q into y power n is called Bernoulli's equation. If you observe the given equation, it is similar to linear differential equation. What is linear differential equation? Dy by dx plus p into y is equals to q. Till here it is a linear differential equation. So whenever we have y power n is there on the right side part, is the extra part, it may be y square, y cube, y power 4. Whatever might be, you have to identify. This is Bernoulli's equation. How to solve this Bernoulli's equation? Let us see working rule to solve Bernoulli's equation. First step is the equation written in the form dy by dx plus p into y is equals to q into y power n. Let it be equation 1. It is called Bernoulli's equation. Second point, we need to divide equation 1 by y power n on both the sides. First write down standard form here, dy by dx plus p into y is equals to q into y power n. Move on to the next line, just divide it by y power n on both the sides. Then we got dy by dx into 1 by y power n plus p into y, py by y power n is equals to q into y power n by y power n. Move on to the next line. If you look into the previous line, 1 by y power n, no? When you bring y power n to the numerator part, then it becomes y power minus n into dy by dx plus p into, we already have y in the numerator. If you bring y power n to the numerator, then it becomes p into y to the power of minus n plus 1, which is equals to, right side part y power n get cancelled, no, left over part is q, and consider this whole equation as 2. In the previous slide we got equation 2, that is y power minus n into dy by dx plus p into y to the power of minus n plus 1 is equals to q. So we have to make this Bernoulli's equation into linear differential equation. For that we have to substitute or put v is equals to y to the power of minus n plus 1. Move on to the next line. Take differentiate on both the sides with respect to x. So it becomes dv by dx is equals to, before going to take derivative, as we all know the formula of derivative of x power n is equals to n into x to the power of n minus 1. Apply the same formula on the right side part, then it becomes minus n plus 1 into y to the power of minus n plus 1 minus 1 into inner derivative dv by dx. Move on to the next line. dv by dx is equals to minus n plus 1 into, here plus 1 minus 1 get cancelled, left over part is y to the power of minus n into dy by dx. Move on to the next line. Keep y to the power of minus n into dy by dx as it is and send minus n plus 1 to the left side part. Then it becomes 1 by 1 minus n into dv by dx. Move on to the next line. Now we are going to substitute this value in equation 2. That is y power minus n into dv by dx is equals to 1 by 1 minus n into dv by dx. We are going to substitute this value in equation 2. That is, we already discussed what is equation 2, right? That is y power minus n into dv by dx. In place of this, we are going to substitute 1 by 1 minus n into dv by dx plus write down remaining things as it is, that is p into y to the power of minus n plus 1 is equals to q. In the previous slide we already got this line, that is 1 by 1 minus n into dv by dx plus p into v is equals to q. Move on to the next line. What we did in this line means, just we are going to multiply it by 1 minus n on both the sides. Then above equation becomes dv by dx plus 1 minus n into pv, which is equals to 1 minus n into q. Now this equation seems like linear differential equation. Next thing we need to find out integrating factor for the above equation. Formula is e to the power integral 1 minus n into p of x into dx. Coming to the next line, solution form of Bernoulli's equation. This is the formula for the solution form for the Bernoulli's equation, that is y to the power of 1 minus n into e to the power of integral 1 minus n into p of x into dx is equals to integral 1 minus n into q into e to the power integral 1 minus n into p of x into dx whole dx plus c. Let us see the example 1. Given question is, solve the differential equation dy by dx plus 1 by x into y is equals to x into y square. First write down given differential equation as it is, that is given that dy by dx plus 1 by x into y is equals to x into y square, which is a Bernoulli's differential equation. Whenever you compare given equation to the standard form of Bernoulli's differential equation, we got the values of p of x, q of x and n. After comparing, p of x value becomes 1 by x, and in place of q of x we have x, and n value we got 2. Next line, we want to find integrating factor for the given equation. Formula is e to the power integral 1 minus n into p of x into dx. Move on to the next line, is equals to e to the power integral. If you substitute n value here, 1 minus 2 becomes minus 1. Minus 1 into p of x becomes minus p of x into dx. Move on to the next line, is equals to e to the power, take outside minus from the integral, so minus integral, substitute value of p of x here, p of x value is 1 by x, no, so e to the power minus integral 1 by x into dx. After the previous slide, we got e to the power of minus integral 1 by x into dx. Integral 1 by x into dx value is log x, no? So that is how we got here e to the power of minus log x. Move on to the next line, which is equals to e to the power, we have a formula that is log a power b can be written as b into log a, no? Using that formula we can write this as e to the power of log x power minus 1. So using anti-logarithm, exponential and log get cancelled. Leftover value is x to the power of minus 1. X to the power of minus 1 can also be written 1 by x. So finally we got integrating factor value is 1 by x. Next line, solution of equation 1 will be, we already discussed, for the Bernoulli's equation this is the solution. So y to the power of, this is the solution form of Bernoulli's equation, that is y to the power of 1 minus n into e to the power of integral 1 minus n into p of x into dx, which is equals to integral 1 minus n into q into e to the power of integral 1 minus n into p of x into dx plus c. Move on to the next line. Before going to substitute values in a general solution, we already know the values of n and integrating factor. Here n value is 2, and just now we got integrating factor value is 1 by x. After substituting integrating factor and n value in the previous slide, we got y to the power of 1 minus 2 into 1 by x is equals to integral 1 minus 2 into x into integrating factor value is 1 by x into dx plus c. Move on to the next line. After solving this, y to the power of 1 minus 2 means y to the power of minus 1. This can be written as 1 by y into 1 by x is equals to integral 1 minus 2 becomes minus 1 now. So take outside minus integral. Here x and get cancelled. So left over part is dx plus c. Move on to the next line. 1 by y into 1 by x becomes 1 by x into y is equals to minus integral dx plus c as it is. Move on to the next line. 1 by xy is equals to minus integrating x into dx becomes minus x plus c. Finally, we got general solution of the given equation is 1 by xy is equals to minus x plus c. Let us see the example 2. Here question is, solve the differential equation is x into dy by dx plus y is equals to x cube into y power 6. First write down given equation. Given that x into dy by dx plus y is equals to x cube into y power 6. It looks like a Bernoulli's differential equation. Move on to the next line. What we did in this line means we are going to divide it by y power 6 throughout the inequality. Then given equation becomes x by y power 6 into dy by dx plus y by y power 6 is equals to x cube into y power 6 by y power 6. Move on to the next line. X by y power 6 into dy by dx plus here y 1 y cancel in the numerator and denominator, resultant becomes 1 by y power 5 is equals to, here y power 6 cancel, left over part is x cube. Move on to the next line. Again here we are going to divide it by x throughout the inequality, then numerator x and denominator x cancellation. So we got 1 by y power 6 into dy by dx plus 1 by x into y power 5 is equals to x cube by x. Move on to the next line. 1 by y power 6 into dy by dx as it is, plus, write down separately, 1 by x into 1 by y power 5 is equals to, here x cube get cancelled, so left over thing is x square in the numerator part. Let this value equation 1. Now we are going to make this Bernoulli's equation into linear differential equation. For that we took z is equals to 1 by y power 5. Move on to the next line. Take derivative on both the sides with respect to x. Then left side part becomes dz by dx is equals to. Before going to solve the right side part, have a look into the since part. Derivative of y to the power of minus 5 is equals to, as we all know the formula, that is derivative of x power n is equals to n into x to the power of n minus 1. Using that formula, minus 5 into y to the power of minus 5 minus 1. So we got minus 5 into y to the power of minus 6 into inner derivative is dy by dx. Now come back to our value. So on the right side part, after doing derivative, we got minus 5 by y power minus 6 becomes minus 5 by y power 6 into dy by dx. Move on to the next line. Next, bring minus 5 to the left side part, then it becomes minus 1 by 5 into dz by dx is equals to 1 by y power 6 into dy by dx, and let this value be equation 2. From equation 1 we already have equation 1 in the previous slide. Just write down the same equation again here. So 1 by y power 6 into dy by dx plus 1 by x into 1 by y power 5 is equals to x square. This is equation 1. This is already we have in the previous slide. Move on to the next line. By using equation 2, substitute minus 1 by 5 into dz by dx in place of 1 by y power 6 into dy by dx. What we are going to do means we are going to substitute equation 2 value in equation 1. Then it becomes minus 1 by 5 into dz by dx plus 1 by x into, we already gave name for 1 by y power 5 is z, no, just replace 1 by x into z, which is equals to x square. Move on to the next line. We are going to multiply with minus 5 on both the sides. In the previous slide, after multiplying minus 5 on both the sides, we got dz by dx minus 5 by x into z is equals to minus 5 into x square. This condition looks like a linear differential equation. In general form of linear differential equation is dz by dx plus p into z is equals to q. If you compare our equation to the standard linear differential equation, we got the values of p and q. That is, we got p is equals to minus 5 by x, and in place of q we have minus 5 into x square. Next line, we are going to find out integrating factor for the given linear differential equation, and we know the formula is e to the power of integral p into dx, which is equals to e to the power integral. Just in the previous line we got the value of p, just substitute here, minus 5 by x into dx, which is equals to e to the power, take out minus 5 outside and apply integral 1 by x into dx. Integral 1 by x into dx becomes log x, no? So finally we got e to the power of minus 5 into log x. Next line is equals to e to the power of log, we have a formula log a power b can be written as b into log a, no? Using that formula, here we are going to write e to the power of log x to the power of minus 5. Using anti-logarithm, here exponential and log cancel. The value we got x to the power of minus 1. So this can be written as 1 by x power 5. Finally, we got integrating factor for the given linear differential equation. Next, we need to find out solution for the differential equation. A solution formula is z into integrating factor is equals to integral q into integrating factor dx plus c. Write down z as it is. Just now we got integrating factor value is 1 by x power 5. No, just write down which is equals to integral. In the previous slide we got the value of p and q. No, in place of q write down value that is minus 5 into x square into integrating factor means 1 by x power 5 into dx plus c. Move on to the next line. Z into 1 by x power 5 is equals to, from the integral take outside minus 5. So minus 5 integral after x square x power 5 cancel, left out part is 1 by x cube into dx plus c. Move on to the next line. Substitute z value here 1 by y power 5 into, write down this value 1 by x power 5 which is equals to minus 5 integral 1 by x cube can be written as x to the power of minus 3 dx plus c. After solving the previous step, we got 1 by x power 5 into y power 5 is equals to minus 5 into x to the power of minus 3 plus 1 by minus 3 plus 1 plus c. How we got the right side part means using integral x power n formula. Integral x power n formula is x to the power of n plus 1 by n plus 1. Move on to the next line. 1 by x power 5 into y power 5 is equals to minus 5 as it is. Inside the bracket, x to the power of minus 3 plus 1 becomes minus 2 by minus 2 plus c. Move on to the next line. 1 by x power 5 into y power 5 is equals to, here minus minus get cancelled. So, and x to the power of minus 2 can be written as 1 by x square. No. So, finally we got 5 by 2 into x square plus c. Move on to the next line. Therefore, required solution of the given differential equation is 1 by x power 5 into y power 5 is equals to 5 by 2 into x square plus c. Thank you all for sparing your valuable time.